Our next presenter is a graduate of BS Mathematics. She has a master's degree in mathematics education. She served public school for 9 years. She is a grade 10 teacher and currently Teacher2 at HHIS Integrated School. Let us all welcome Mrs. Sonia J. Daganyo.
Thank you, Ma'am Karen, for that wonderful introduction. To our OIC Schools Division Superintendent, Dr. Romela M. Cruz. Our OIC Office of the Assistant Schools Division Superintendent, Dr. Aurelio G. Alfonso. CID Chief Education Supervisor, Dr. Aline G. Mendoza. SGOD Chief, Ma'am Emma G. Arubio. To all the SDO officials, to the hardworking education program supervisor in mathematics, Mr. Resty I. Rodelas, to our very supportive principal, Dr. Efren S. Consimino, Highway Hills Integrated School Community, sa mga Batang MANDunong and home learning partners, a pleasant afternoon. Welcome to our project series of online academic reviews of mathematics grade learning modules. I am your Project SOAR Math Reviewer for the pre-calculus for week 1.
Good day everyone! Welcome to our project series of online academic reviews of mathematics grade learning modules. I am Sonia J. Daganyo, your Project SOAR Math Reviewer for pre-calculus for week 1. Is everyone ready? Let's begin! Today's competencies, we have first, illustrate the unit circle and the relationship between the linear and angular measures of a central angle in a unit circle. Second, convert degree measure to radian measure and vice versa. To start with, here is the objectives for our lessons today. First, express the given angle in degrees, minutes, and seconds, and in degrees alone. Second, sketch the following angles measured in degrees in standard position. Third, determine the quadrant in which each angle lies. Fourth, convert degree measure to radian measure and vice versa. And fifth, solve problem applying the conversion of degree measure and vice versa. For the recap, let us recall the key concepts of involving angles. An angle is a plane figure consisting of two rays having the same endpoint. The sides of an angle are the rays. One is the initial side, and the other is the terminal side. A central angle of a circle is an angle whose side's common endpoint, its vertex, is at the center of the circle. An arc intersected by a central angle is the part of the circumference of the circle swept by the central angle from initial to terminal side. In this case, we also say that the arc subtends the central angle. Lesson proper. An angle is formed by rotating a ray about its endpoint. The initial side of angle AOB is ray OA, while its terminal side is ray OB. An angle is said to be positive if the ray rotates in a counterclockwise direction, and the angle is negative if it rotates in a clockwise direction. If an angle fits a coordinate system in which the origin is the vertex and the initial side coincides with the positive x-axis, then this angle is said to be an angle in standard position. The angles alpha, theta, and beta in figure below are angles in standard position. The angle alpha, the terminal sides rotates clockwise, and the angle theta, the terminal sides rotates counterclockwise, while the angle beta rotates clockwise. In other words, this angle is negative. To measure angles, we use degrees, minutes, seconds, and radians. An angle of a circle measures 1 degree, written 1 degree, if it intercepts 360 of the circumference of the circle. 1 minute, written 1 apostrophe, is 60 of 1 degree, while 1 second, written 1 double apostrophe, is 60 of 1 minute. 1 degree equals 60 minutes and equals 3,600 seconds. 1 minute equals 1 over 60 degrees, and 1 second equals 1 over 3,600 degrees. How to express decimal degrees to degrees, minutes, and seconds? First, for the degrees, use the whole number part of the decimal. Second, for the minutes, multiply the remaining decimal by 60. Use the whole number part of the answer as minutes. Third, for the seconds, multiply the new remaining decimal by 60. Example number 1. Express 29.125 degrees in degrees, minutes, and seconds. For the degrees, use the whole number part of the decimal, so that is 29 degrees. For the minutes, multiply the remaining decimal by 60 and the product is 7.5 minutes. So the whole number 7 becomes the minutes. For the seconds, multiply the new remaining decimal 0.5 times 60 and the result is the seconds. So, 29.125 degrees equals 29 degrees, 7 minutes, and 30 seconds. Example number 2. Express 15 degrees, 26 minutes, and 18.2 seconds in degrees alone. Note, 1 degree equals 60 minutes and equals 3,600 seconds. 1 minute equals 1 over 60 degrees and 1 second equals 1 over 3,600 degrees. To express this in minutes and seconds to decimal degrees, multiply 26 minutes by 1 over 60 degrees and multiply 18.2 seconds by 1 over 3,600 seconds. Then, i-cancel natin dito yung minutes and also sa seconds. Using the calculator, the result of 26 over 60 degrees is 0.433 degrees and 18.2 over 3,600 degrees is 0.005 degrees. So, we are going to add the result. Therefore, 15 degrees, 26 minutes, and 18.2 seconds is equal to 15.438 degrees. Angles measured in degrees in standard form. The vertical and horizontal lines divide the circle in 2 quarters. Since One full rotation is 360 degrees. Each quarter rotation is 90 degrees. In this figure, the terminal side rotates counterclockwise and the angles are positive. So ito po yung angles in degrees in standard form. Recall, the unit circle is the circle given by the equation x squared plus y squared equals 1, where the center is at the origin and radius 1 as shown in the figure. A central angle of the unit circle that intercepts an arc S of the circle with length 1 unit is said to have a measure of 1 radian. This angle measures 1 radian. A radian is the measure of an angle theta that, when drawn as a central angle, subtends an arc whose length equals to the length of the radius of the circle. So, 1 radian equals 180 degrees over pi, approximately 57.3 degrees. Since the circumference of a circle is 2 pi r units, it follows that a central angle of 1 full revolution counterclockwise corresponds to an arc length of S equals 2 pi r. Also, the radian measure of an angle of 1 full revolution in a unit circle is 2 pi. Kung sa previous circle ang angle measure na ginamit natin ay degrees, so in this unit circle, ang angle measurement na gagamitin natin ay radian measurement in terms of pi. One complete rotation angle measures 360 degrees equals 2 pi radians. So, ang 1/2 rotation is pi radians. So, in degrees, ito ay 180 degrees. And 1/4 revolution is equal to pi over 2 radians. So, sa degrees, this is 90 degrees. And 3/4 revolution equals 3 pi over 2 radians. Then, the 1/8 revolution is pi over 4. Dahil nga 1/8 siya ng 2 pi. So, from here to this point, ang angles is 5 pi over 4. Kung mapapansin natin, ang ikot natin ay 1/2 revolution. So, ang 1/2 revolution is pi. So, paano nakuha yung 5 pi over 4? Yung pi ay pwedeng maging 4 pi over 4 is equal to pi. So, i-add natin si 4 pi over 4 sa pi over 4, kaya siya naging 5 pi over 4. Next, 1/12 revolution is equal to pi over 6 radians. So, from this point to this point again, ang ikot niya ay 1/2 revolution. So, ano kaya ang magiging angle measurement dito? Okay. So, yung pi, ang equivalent niya ay 6 pi over 6. So, kapag inad natin si 6 pi over 6 at saka pi over 6 is equal to 7 pi over 6. Then, the 1/6 revolution is equal to pi over 3 radians. So, from this point again, ang measurement ng ating angle is 4 pi over 3. So, paano ulit naging 4 pi over 3? Kasi ang ikot nga niya is 1/2 revolution, so that is pi. So, ang equivalent niya is 3 pi over 3 equals pi. So, i-add natin yung 3 pi over 3 sa pi over 3. The answer is 4 pi over 3. So, kapag itinuloy natin, ito yung mga angle measurement in radians. So, in this figure, angles measured in radians in standard form. So, this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So, in this figure, some spatial angles and standard position with the terminal sides, the degree and radian measures are given. Sketch the following angles measured in degrees in standard position. Example, 140 degrees. In x and y coordinate plane, the initial side lies along the positive axis and the degree is 0. Ang angle natin ay positive. Kaya ang movement ng terminal side from initial side is counterclockwise. And 140 degrees is greater than 90 degrees and between siya ng 90 degrees and 180 degrees. Approximately, ang position ng terminal side natin ay dito. So, this is the sketch of 140 degrees. Next example. Ang next angle natin is positive. So, that is 70 degrees. So, ang movement ng ating terminal side from initial side is counterclockwise. So, from initial side, ang terminal side natin ay approximately dito siya naka-position. Dahil ang 70 degrees is between siya ng 0 degree and 90 degrees. So, this is the sketch of 70 degrees. Third example, negative 155 degrees. Ang angle natin is negative. Kaya, ang movement ng terminal side from initial side is clockwise direction. Saan kaya ang position ng terminal side natin? Since negative 155 degrees is between negative 90 degrees and negative 180 degrees, approximately, dito ang position ng terminal side. So, ito ang sketch ng negative 155 degrees. And the fourth example is negative 40 degrees. Again, our angle is negative. So, ang direction ng terminal side from initial side is clockwise direction. Since negative 40 degrees is malapit sa 0, approximately, ang position ng terminal side ay dito. Okay, so ito ang sketch ng negative 40 degrees angle. Determine the quadrant in which each angle lies. Example number 1, pi over 4 radians. We have x and y axes labeled in radian measures and the location of first quadrant, second quadrant, third quadrant, and fourth quadrant. The given angle in radian is positive. So the rotation of terminal side from initial side is counterclockwise. Since 1/4 pi radians is less than 1/2 pi radians, therefore, pi over 4 lies in first quadrant. Second example, 5 pi over 6 radians. So, ang ikot ng terminal side from initial side is counterclockwise. Kasi positive ang ating angle. Ang equivalent fraction ng pi is 6 pi over 6. So, 5 pi over 6 is between siya ng pi over 2 radians and pi. Therefore, 5 pi over 6 lies in second quadrant. Third example, negative 3 pi over 4 radians. The angle radian is negative. The movement of the terminal side from initial side is clockwise direction. The equivalent fraction of negative pi is negative 4 pi over 4. Ang negative 3/4 pi radians is between negative 1/2 pi radians and negative pi. Therefore, the negative 3 pi over 4 lies in the third quadrant. Fourth example, negative pi over 3. The directions of the terminal side from initial side is clockwise. And negative pi over 3 is between 0 and negative pi over 2. Therefore, the negative pi over 3 lies in the fourth quadrant. Let us proceed in conversion. Converting degree to radian and vice versa. To convert a degree measure to radian, multiply it by pi over 180 degrees. To convert a radian measure to degree, multiply it by 180 degrees over pi. Converting degree to radian. Examples. Express 120 degrees, negative 60 degrees, and 240 degrees in radians. 120 degrees times pi over 180 degrees equals 120 pi over 180. To reduce this in lowest term, get the greatest common factor of 120 and 180, which is 60. Cancel out 60. Therefore, 120 degrees equals 2 pi over 3 radians. Negative 60 degrees multiply by pi over 180 degrees is negative 60 pi over 180. To reduce 60 over 180, get the greatest common factor, which is 60, then cancelled out. Therefore, negative 60 degrees equals negative pi over 3 radians. 240 degrees times pi over 180 degrees equals 240 pi over 180. Reduce this in lowest term. So, we are going to cancel out the greatest common factor of 240 and 180, which is 60. Therefore, 240 degrees equals 4 pi over 3 radians. Converting radian to degree. To convert a radian measure to degree, multiply it by 180 degrees over pi. Examples. Express 5 pi over 2 radians, pi over 4 radians, and negative 7 pi over 6 radians in degrees. So, i-multiply natin ang 5 pi over 2 sa 180 degrees over pi. Then, i-cancel natin yung pi. So, the product is 900 degrees over 2. Therefore, 5 pi over 2 equals 450 degrees. Pi over 4, multiply natin sa 180 degrees by pi. So, na-cancel yung pi. So, the result is 180 degrees over 4, which is 45. So, therefore, pi over 4 equals 45 degrees. Negative 7 pi over 6 multiply to 180 degrees over pi. Cancel natin yung pi. So, the product is negative 1,260 degrees over 6. So, therefore, negative 7 pi over 6 equals negative 210 degrees. One of the applications of conversion from degrees to radian measure and vice versa is finding the arc length and area of a sector. In a circle, a central angle whose radian measure is theta subtends an arc that is the fraction theta and 2 pi of the circumference of the circle. Thus, in a circle of radius r, the length of an arc that subtends the angle theta is S equals theta over 2 pi times circumference of circle equals theta over 2 pi times 2 pi r equals r theta. So, kinansel dito yung 2 pi kaya siya naging r theta. So, the formula of arc length is S equals r theta. So, ito yung arc length sa circle. Example number 1. Find the length of an arc of a circle with radius 4 meters that subtends a central angle of 30 degrees. So what are the given? We have the radius, which is 4 meters, and theta equals 30 degrees. Since the given central angle is in degrees, we have to convert it into radian measure. So that is 30 degrees multiplied to pi over 180 degrees. So the result is pi over 6 radians. So yung theta natin, naka-convert na siya sa radians. Then, we are going to apply the formula for an arc length. Then, we are going to substitute the value of radius and theta, which is 4 meters and pi over 6. So, to get the product of 4 meters times pi over 6, we have 4 pi over 6 meters, or 2 pi over 3 meters, approximately 2.09 meters. Therefore, the length of an arc of a circle is 2 pi over 3 meters, approximately 2.09 meters. Example number 2. A central theta in a circle of radius 3 meters is subtended by an arc length of 2 pi meters. Find the measure of theta in degrees. So, what are the given in the problem? We have radius equals 3 meters and the arc length is 2 pi meters. Using the formula of arc length, which is S equals r times theta, we derive the formula in getting the measure of the central angle in radian. So, we have theta equals S over R. Then, we are going to substitute the values of R and S in the given formula. So, theta equals 2 pi meters over 3 meters. Then, we are going to cancel the meters. So, we have 2 pi over 3 radians. Since we are required to get the equivalent degree measure, we convert 2 pi over 3 radian to degrees. So, we have 2 pi over 3 times 180 degrees over pi equals 360 degrees over 3 equals 120 degrees. Therefore, the measure of theta in degrees is 120 degrees. Area of a sector. A sector of a circle is the portion of the interior of a circle bounded by the initial and terminal sides of a central angle and intercepted arc. Note that an angle with measure 2 pi radians will define a sector that corresponds to the circle as a whole. Therefore, if a central angle of a sector has measure theta radians, then the sector makes up the fraction theta over 2 pi of a complete circle. Since the area of a complete circle with radius r is pi r squared, we have the area of a sector equals theta over 2 pi times pi r squared, which is equal to 1/2 times theta times r squared. So in this illustration, the shaded portion is the area of a sector. Example, find the area of a sector of a circle with central angle 30 degrees if the radius is 4 meters. Given, since the radius is equal to 4 meters and theta equals 30 degrees. Since the given angle is in degrees, we convert it first to radian measure. So that is 30 degrees multiplied to pi over 180 degrees equals 30 pi over 180. And the lowest term is pi over 6 radians. Then we are going to substitute the value of radius and theta. So 1/2 times pi over 6 times the square of 4 meters. So we have 16 pi over 12 dahil 1 times pi times 16 kaya siya naging 16 pi. Then the denominator 2 times 6, so that is 16 pi over 12 equals 4 pi over 3. Thus, the area of a sector of a circle is 4 pi over 3, approximately 4.19 meters. For the activities, complete the table. So, in the table, the given radius is 3 cm. Angle in degrees is 140 degrees. So we are going to find the angle in radian, the arc length, and area of a sector. To find the angle in radian, we are going to convert the 140 degrees in radian. So 140 degrees times pi over 180 degrees equals 140 pi over 180. So the lowest term, we have 7 pi over 9 radian. For the arc length, we are going to apply the formula, which is S equals R times theta. So, since the radius is 3 cm, multiply to 7 pi over 9. So the result, we have 7 pi over 3 cm, approximately 7.33 cm. For the area of the sector, we are going to apply the formula, which is A equals 1/2 times theta times the radius squared. So, to substitute the value, so we have 1/2 times 7 pi over 9 times 3 cm squared. So we have 7 pi over 18, then the square of 3 cm is 9 cm squared. So we are going to cancel 9 and 18 by their GCF, so which is 9. So the answer is 7 pi over 2 cm squared. Approximately 11 centimeters squared. The radius 6 centimeter and arc length 6 pi over 6 centimeter are given in this table. So we are going to find the angle in degrees, angle in radian, and area of the sector. To find the angle in radian, we are going to apply the formula of arc length, which is S is equal to R times theta. Since given yung arc length, so we are going to use this formula. Theta equals S over R. So, substitute the value of arc length and the radius. We have 11 pi over 6 meters over 6 meter equals 11 pi over 6 times 1 over 6 equals 11 pi over 36. So, this is the radian. Angle in degrees. So, to find the angle in degrees, we are going to multiply the 11 pi over 36 to 180 degrees over pi. So, the result is 1980 degrees over 36 equals 55 degrees. For the area of the sector, we are going to apply the formula, which is A equals 1/2 over 2 theta r squared. So, the theta or the radian is 11 pi over 36 times 6 centimeter squared. So, we have 1/2 times 11 pi times 36 centimeter squared. Then, we are going to cancel the 36. So, ang naiwan na lang ay 1, the 11 pi over 2 centimeter squared. Approximately 17.28 centimeter squared. So, that is the area of the sector. Thank you for watching and listening. Happy learning. Goodbye.